topologies versus the OSI, or sorry, the network topologies, the OSI model versus the TCP/IP model. We'll touch on some of the network devices and look at the fundamentals of virtual and cloud computing. I do want to point out this does not replace the reading material, so please make sure that you read the material, do the explore activities, complete the watch the videos, and take the quizzes. Excuse me, and that, along with the cohorts, can benefit you greatly for the exam. The exam is not a killer, but it isn't easy. And this isn't a course that you can just kind of read through the material once there, unless you have experience. But there are a lot of terms that you need to be able to memorize. I'm going to go ahead and I need to open up the chat here. So the first thing I want to start off with is, what is a network? So you can put this in the chat, but what do you think a network is? What kind of devices do you have in your homes? What are some of the devices that you have in your work environment? What do you think? I'm pretty sure many of you probably have routers or a wireless router. What other devices? Smart devices, our cell phones. You might have laptops or tablets. Those are all part of your home network. And in an organization, you're going to see switches and servers, routers, cell phones, cabling. All of that makes up a network. And a network is just basically a collection of devices that allow you to share resources and access resources. So when we go through the material, when you go through the material, don't confuse the network with the internet. The internet is a collection of networks, and all of the information that you're going to be reading about in the course material is covering a network. So that's the difference in how you create that network so that you can access another network and share information within your own network. So let's talk a little bit about network devices. So you've got a hub and a switch. Now we're going to talk a little bit about how you create a network topology. Well, in a star topology, you have devices connected to a hub or a switch. A hub is a dumb device. It doesn't know where packets are coming from, doesn't know where they're going. It uses electrical signals to push those packets to every port that has a device connected to it. It sits at the physical layer of the OSI model. Then you have the switch. And to go back to the hub, you're not going to see hubs in any of our organizations. One, because it does slow the network down. You may get a question that talks about having hubs within that organization, but in the real world, you're just not going to see them. Then we have switches. Switches are smart. They know where packets are coming from. They know exactly where they're going based off MAC addresses. All of our devices, network devices, have a unique MAC address, and that MAC address is stamped or burned onto the network interface card. And there isn't one device that has the same MAC address. So think of it like your social security number. You're the only one that has that number. There isn't anybody else out there that has that same number. So because of that, when switches receive a packet, they know exactly where to send it based off that MAC address from the built table the table that they built. So switches are smart. Also, switches have the ability to add extra security that the hub doesn't. Now, I want to point out, neither one of these devices enables us to be able to connect to another network. They don't have that capability. The only device that has that ability is the router. The router is what connects us to another network. You have to have an IP address in order to connect to another network. And the router sits at the network layer of the OSI model. It forwards packets. So you can have a wired router or a wireless router. Most of us in our homes probably have wired routers. Now, to go back to the switch, if you are doing any of the explore activities, one of the activities has you place the switch on the data link layer or layer 2 of the OSI model, and it has you move it over to layer 3, the network layer. I want to point out the only time a switch would ever be at the network layer is if it was a combination or a combo device. And that means that it acts as both a switch and a router, which is not uncommon with the devices that we have with our cable, and you will see those in an organization. They're called a layer 3 switch or a multi-layer switch, and it has to have those words in order for it to be at the network layer. So I wanted to point that out so none of you were confused when you go to take the exam. Now here we have access points. Now this looks like a wireless router, but it is not what we have in our homes. When you go to take multi-layer switch that we have with our cable and our combo device. So, layer 3, the network, the switch on the data link layer or layer 2. If you are doing any of the Explore activities, one of the activities has you place the switch on the data link layer or layer 2 of the OSI model, and it has you move it over to layer 3, the network layer. I want to point out the only time a switch would ever be at the network layer is if it was a combination or a combo device. And that means that it acts as both a switch and a router, which is not uncommon with the devices that we have with our cable, and you'll see those in an organization. They're called a layer 3 switch or a multi-layer switch, and it has to have those words in order for it to be at the network layer. So I wanted to point that out so none of you were confused when you go to take the exam. Now here we have access points. Now this looks like a wireless router, but it is not what we have in our homes. You're going to see these in organizations. Our organizations are wired, and that is because wired networks are faster and they're more secure, and because organizations are usually dealing with employee sensitive data information like our social security numbers, our home address, might be using customer information, or if you work in a hospital or any kind of medical facility, you can't use wireless. It's just not as secure. So they implement access points. They're interconnected to the wired network to enable some wireless capability within that organization. You're going to see them mounted towards the ceiling, either in somewhere in the building or in your office. But that's what they are. They're and they sit at the data link layer of the OSI model. All right, so I have a few questions for you here. First question is, which of the following devices forwards data packets to all connected ports? Is it a switch, a router, a hub, or an access point? What do you think? If you said hub, you are correct. Next question, which of the following devices passes data based on MAC addresses? Is that a switch, a router, a hub, or a modem? Yes, if you said switch, you are correct. So let's take a look at the network topologies. So a topology is how the types of devices, the way they're set up, and the type of cabling to create that network. Now, in your home, more than likely, you probably have what we call a wireless local area network. It's a LAN. It's a limited area network. When you walk into a building or into your work environment, those are local area networks. When we talk about network topologies, we're talking about how we're setting that network up within that local area network. And within that local area network, we have a protocol and we have a topology. And the protocol is a set of rules. These are established so users can gain control of the network to exchange information. And the topology is the network architecture, and it's used to interconnect the networking equipment. Think of a topology as kind of like if you build a home or the type of home you have. You might live in a ranch, you might be building a ranch, a 2-story with a walkout basement. Maybe it just has a basement. There's all different types of ways to build homes, just like there is with the topology, but you need different types of material to build those homes. And think of a topology in that way. And we're going to talk about the star topology, the ring topology, and a ring topology is sometimes referred to as a token ring. And we'll talk about the bus. So I want to start off with the bus topology. It is the oldest topology out there. Now, when we talk about these topologies, we are not talking about accessing the internet. It's about sharing resources within that network, that local area network. When bus topologies were created, there wasn't an internet. They were created because at the time there was no way for employees or coworkers to be able to share information. Either they had to print it out and walk it over or distribute it to the employees, or they saved it on a floppy drive and they would have another coworker download it on their device. So they came up with a bus topology. The bus topology is easy to set up and it's very inexpensive. Devices are directly connected to this cable. And it uses electrical signals, kind of like how I described the hub, because it doesn't know where packets are coming from or where they're going. And so when a device is trying to complete a task, let's say that this PC1 wants to print. First of all, devices can only connect to this bus topology one at a time. So all the other devices have to wait their turn. So that is something that we definitely aren't used to. Those packets can only move in one direction at a time. That's why the cables are terminated at each end, because the packet has to be able to turn around and go back in the other direction. It's what we call half duplex. And it uses electrical signals to push those packets through this cable. It actually connects to every device to see if it is, say, in this instance, the PC wants to print. And so it isn't something, like I said, that we're used to. And so the devices here are a first come, first serve. But at that time, no one knew any different. And so it was, looked at as being an amazing new technology. So in our organizations, there are hundreds of devices. So what they did and how they handled the bus topology, you can only have a few devices at a time or connected to one cable. The bus topology is a segment of that network. So you might have a bus topology segment in each, say, office or in each department. You are only going to have probably no more than 10 devices connected to that bus topology. And as you can see, there are no server or no hubs and no switches that are connected to this hub or to this cable. So just remember, a bus topology is easy to set up. It's inexpensive. Devices are directly connected to that cable, and it is a first come, first serve type situation. Without a Mac, is PC1 asking all devices to print? I'm not sure what you meant. It's just that these are just devices that are connected to the cable. So it's just that they just put in this image, they just have different types of devices. I don't even know if there was Mac computers back then, but they just named it so that you could see that there's different devices connected to this cable. Hopefully that's answering your question. But like I said, it's a first come, first serve, and whatever device is connected to that network, all the other devices have to wait. And then we came up with the token ring. The token ring was actually created to overcome that first come, first serve. Now we still use token rings or ring topology, but we use them for very specific reasons. It's not common. And what made this better than the bus topology is that tokens were passed to devices at set times so they could connect to the network. You still don't see a switch or a hub in this particular topology, but devices are daisy chained to each other. They connect to the left and right of them, creating this continuous loop, or sometimes referred to as a path that ends where it begins. Now, they don't talk about it in the course material, but how they pass the tokens around is they use a device called an MAU. and that's what passes the tokens. You don't need to know that for the exam, but that's how they pass the tokens around to each device. And then we have the star topology. Now the star topology is around to each device. Use AU referred to as topology, but devices are daisy chains.
Oh, what? These are the same
to
thing.
each other. They connect to the left and right of them, creating this continuous loop, or sometimes referred to as a path that ends where it begins. Now, they don't talk about it in the course material, but how they pass the tokens around is they use a device called
They got the wrong.
an
What?
MAU. Token or and then we came up with the token ring. The token ring was actually created to overcome that first come, first serve. Now, we still use token rings or ring topology, but we use them for very specific reasons. It's not common. And what made this better than the bus topology is that tokens were passed to devices at set times so they could connect to the network. You still don't see a switch or a hub in this particular topology, but devices are daisy chained to each other. They connect to the left and right of them, creating this continuous loop, or sometimes referred to as a path that ends where it begins. Now, they don't talk about it in the course material, but how they pass the tokens around is they use a device called an MAU, and that's what passes the tokens. You don't need to know that for the exam, but that's how they pass the tokens around to each device. And then we have the star topology. Now, the star topology is the most common topology used today. It's probably, you may not realize it, but when you go into an organization or in your work environment, even if you were at school in a computer lab, they're all using star topologies. I want to point out, you do not have devices all set in a circle with a hub or a switch in the middle. It is logically set up that way. Physically, it might look like devices are in a row, like a bus topology. So, but logically, it's set up this way. What you have is you've got network devices, computers, laptops, printers, servers, connected to a hub or switch using twisted pair cable. And now twisted pair cable can be called CAT cable, can be called UTP cable. It all means the same thing. CAT6A is our most common twisted pair cable that we're using. But you've got, say you have a laptop that you work with at work. That laptop or desktop computer has a CAT cable that's plugged into its port, and then it's plugged into a wall plate. Behind that wall plate is a patch cable, and that patch cable runs down into our wiring closet and connects to a hub or a switch. Now, hubs and switches have ports on the back, and each device can have 24, 32, or 48 ports, depending on what size device you buy. That means that's how many computers can connect to that device, creating that star topology. And I want to point out, most of our organizations have multiple devices. You can have 500 devices within that network. And so if you divide that by 48, that would be how many switches you would need. So just like how I described the bus topology, the star topology is going to be set up in segments within that network or that organization, still all falling under the same network. So one of the downsides of the star topology is that it has what we call a single point of failure. And what that means is the devices that are connected to that hub or switch, if they break or it doesn't, it's not functioning anymore, the devices that are plugged in to that hub or switch will not be able to connect to the network until it's replaced or repaired. That's what it means by a single point of failure. Now, that organization might have several switches. So just because this one segment that has 48 devices, say that switch or hub breaks, they're not going to be able to connect to the network, but the other switches within that network will be able to. Now, I want to point out, all of these devices are independent of each other. So what that means is that you can connect to the network anytime you want, just like this is what we're used to. So they don't have to wait for a token. They don't have to wait until it's their turn, or a first come, first serve situation. If you unplugged or disconnected one of the devices from the hub or switch, it still doesn't affect any of the other devices. So just remember that the star topology is the most common topology, and that it does have a single point of failure. Now, here we have the mesh topology. Mesh topologies are for very large organizations. They're complicated and they're very expensive. You can have a wireless mesh and you can have a wired mesh, depending on what the organization wants to set up. Now, like the star topology had the single point of failure, with a mesh topology, the advantage of this is that it offers redundancy or fault tolerance. So what that means is if there's a device that's down, say the switch or the hub, it will just reroute. So if one path is down, there's another path open.
But because of that, all the network devices are heavily interconnected, which makes it complicated and expensive because network devices are expensive. So just remember, it's for a large organization and it's complicated. All right, so I have a few questions for you on this. So what is the most common network topology today? Is it a star, a hub, a ring, or a mesh? Yep, if you said a star, you are correct. Next question, true or false? A protocol defines the network architecture that's used to interconnect the networking equipment. Is that true or false? What do you think? A protocol defines the network architecture used to interconnect the networking equipment. Is that true or false? If you said false, you are correct. That is because the networking protocol is the set of rules established for users to exchange information, and the topology is the network architecture that's used to interconnect the networking equipment. All right, so now we're going to talk about the TCP/IP model versus the OSI model. Now, this is one area that students have a lot of, usually, if they do meet up with me, this is an area that they struggle with. There is a lot of information to remember, but I'm going to give you some keywords and a brief description that I want you to write down that will help you no matter how one of the questions are worded in one of the practice quizzes or on the exam. So the OSI model and the TCP/IP model, they were created in the 80s. And they were created to allow us to be able to connect to other networks so that we could share information without our networks being set up the same. So we've had networks for a very long time. In the 60s, the science labs, they had their own networks, but they didn't have the TCP/IP model or the OSI model. So they couldn't share information between each other unless their networks were set up the same. Now remember, when I say network, we're not talking about the internet. There was no internet back then. Military had networks also. So the TCP/IP model has 4 layers, and the OSI model has 7, but they use the same protocols, services, and functions. So they're the same. It's just that the TCP/IP model has fewer layers, and it combines some of the layers of the OSI model. Now, I tell students to learn the OSI model first. It makes it easier. You do need to know that layer 1 of the OSI model is called the physical layer, but layer 1 of the TCP/IP model is called the network interface. And the network interface is a combination of the physical and data link layer. One way to help you to remember this, now I know in the reading material it has a different, there's something different, it's called something different, but I start with layer 7 and move down, and I usually say all people seem to need Domino's pizza. Now you can make up your own, whatever works for you, but if you write this down, because you can use a whiteboard during the exam, if you go ahead and write this, the full all people seem to need Domino's pizza, and then circle the first initial and erase the rest of it, at least it gives you the first initial, and you can kind of figure out what it's talking about. Same thing here. I guess you could make up your own. I can't think of something off the top of my head. But remember that at the application layer with the TCP/IP model, it's dealing with HTTP, FTP, Telnet, NTP, the DHCP servers, the command ping. It's still a combination of the session, presentation, and application layer. And you might see also IMAP or POP, which is an email protocol. I wanted to add those to that. You may not see that in the reading material. But like I said, the protocols, services, and functions are the same for either one. So the TCP/IP, it stands for Transmission Control Protocol, Internet Protocol, and it's just a set of protocols. Remember, we just talked about protocols being, a set of rules, but they're used to connect network devices to each other. It's got 4 layers. It uses the same functions and services and protocols that the OSI model does. Now, when you get questions on the exam, it's not going to try to trick you and not let you know if it's talking about the TCP/IP model or the OSI. So pay special attention. When you get a question, sometimes we read the question quickly and you may not notice it. So get into the habit of reading the question more than once. Now, the OSI model, it's a framework. It ensures compatibility with the hardware and software. Remember, I said it's a set of standards. It's also used to develop software and network technologies. And like I said, on the exam, it's going to let you know if it's talking about the OSI model or the TCP/IP model. So this is where I want you to write down the keywords and that brief description I was talking about. So we start with the The physical layer. Now, one thing I want to point out is that it never skips a layer. It does. It happens in the background, and it's happening in milliseconds. It can send and it can receive. So keep that in mind. Is it sending the packet or is it receiving the packet? So the physical layer, it deals with bits. I want you to write that down, B-I-T-S. Now, if any of you have taken the Network Plus or have to take the Network Plus, you're going to notice that it calls it a PDU, a Protocol Data Unit. I just say the physical layer deals with bits, but you could get a question that says, talks about the physical layer and its PDU. So if you see that out in anywhere else, that's what it means. Protocol Data Unit, physical layer deals with bits. The physical layer deals with our signals and our media. Now, media is cabling, and sometimes it's called medium. They mean the same thing. But all of the cabling is at the physical layer. One, it uses signals to push packets through it. The network interface card, it operates at the physical layer. So all of our devices, every single network device has a network interface card. It allows you, depending on like our laptops and desktops, it's going to allow, that NIC card is going to allow you to be wired or wireless. Now, other network devices like our tablets doesn't have the ability to be wired. But they still have a network interface card. That network interface card, remember, has that unique MAC address that's burned onto it. So if the network interface card isn't working and it has to be physically replaced, it's not operational. So it operates at the physical layer. Now, we talked about the hub and we talked about the switch when you create that star topology. The hub sits at the physical layer because it uses electrical signals. It can't think, can't do anything, it can't process. The devices at the physical layer are not there because they're physical devices. It's the way they work. So the hub, remember, pushes packets to every port that has a device connected to it using electrical signals. It's dumb. The modem sits at the physical layer because it converts analog signals to digital or digital to analog. You're going to learn about DSL modems, satellite modems, cable modems. The repeater is at the physical layer because it extends and regenerates the signals either in our cable or if we're trying to move away with our wireless router. Now, some of you may already have this. If you have an area in your home that doesn't get a great connection with your wireless router, maybe there's a few barriers like walls and stuff that kind of contribute to it, or you're too far away, you can use a repeater. You plug it into the wall outlet, it uses electrical signals, and it can help extend that signal. Oops. The data link layer, it deals with frames. It provides for the flow of data between devices and between the layers. That's all it's doing. It works with our MAC addresses. Remember the data link layer, or the switch I said worked with MAC addresses? It builds a table. That's why it knows where packets are coming from and exactly where they're going. Well, the switch is going to sit at the data link layer. A bridge is an old device. It sits at the data link also, and it has one input and one output port. It came before the switch. It was used to split the network. So remember I said we talked about the different topologies and how they can be segmented? Well, you can have a star topology and a ring topology within the same organization's network. You'd use a bridge to bridge those, or you might use a bridge to add another segment. So you might see a definition that refers to the bridge as being acting like a router in the fact, or acting like a router in the fact that it receives packets, but it forwards packets without analysis. It's an old device. You will not see it in any organization. And then remember, I also said that the access points are at the data link layer. Then we have the network layer. Keyword here, packets. It provides the routing decisions. It's where the routing decisions start. So if you're at home, you're trying to access your student portal, you type in WGU student portal address, that is going to first be routed to your wireless router. Because remember, you need that router to connect to another network. It also works with our IP protocol suite. Now, the IP protocol suite includes our IP addresses, IP version 4, IP version 6, IPX, IP security, which if you shorten it, it's IPsec. Also, our ICMP packets are at the network layer, and you have a router that sits at the network layer because a router forwards packets and it works with our IP addresses. Another thing I didn't point out, I forgot two things. One, an IP address can be called a logical address, and a MAC address can be called a physical address. How you can remember that is that, remember, the MAC address is physically on the network interface card. The IP address, it changes depending on where you're at and what network you're using that device on. So if you have a laptop, it's going to have a different IP address opposed to if you take it to the coffee shop and you connect to their network. So IP addresses are considered logical. Also, I told you that the network interface card operates at the physical layer, but it functions at the data link layer because of that unique MAC address. So there are no other devices past the network layer. Then we have the transport layer. The transport layer literally breaks up the data into packets. It makes sure there's no errors in those packets. And then it looks to see what route it's going to take. Is it TCP or UDP? Now, the PDU for transport is segments. I did forget. So like I said, it breaks the data into segments, into packets. So it uses segments. Now, TCP and UDP. TCP is what we call connection oriented. It guarantees that connection. It offers integrity. UDP, on the other hand, is what we use with media sites, like streaming sites. I said media, I meant streaming. Streaming sites like Pandora, Spotify, Newsfeed. It's a faster connection. It doesn't guarantee the connection. It's called connectionless or an unreliable route. So think of it in terms in this way. Say you order a package. This is going to be an example of TCP. So you order a package and you want to and it requires a signature because it needs to guarantee that you received it. So if you're not home when it gets delivered, it's not going to be left there because it requires a signature. So even though it's guaranteeing that you're receiving the packet, no one's going to come up on your front porch and steal it, and it's not going to be delivered to the wrong address because you've signed for it. It can slow things down because if you're not home when it gets delivered, kind of like how TCP works with it being guaranteeing the connection and being offering integrity. UDP, on the other hand, is like when you order something and it doesn't require a signature. So if you're not home, it's going to be left there. But the problem is what if they have the wrong address? Or what if they leave it and someone walks up and steals it? they're not going to know that you didn't receive it unless you contact them. And so UDP works the same way, kind of like when I said that with the streaming sites. You want a fast connection when you're connecting to Pandora. You don't want to have to keep lingering and lingering. And anyway, if you get disconnected, you just go back and reconnect. So just remember, transport layer deals with segments and just make sure there's no errors in the packets. And the protocols that live there are TCP and UDP. Then we have the session layer. The session layer establishes, manages, and terminates a session. So an example of the session layer, let's say that you go to your student portal, you put in your username and password. At the session layer, it is establishing your connection, but it's also authenticating who you are because you just put your username and password. Once you're in your student portal, the session layer manages that connection. It also works with authorization because what are you authorized to do? You're authorized to look at your degree plan. You're authorized to access your courses. And then when you exit out, it terminates that connection. The presentation layer, keywords, it encrypts and decrypts. Anytime you get a question, even if you don't understand what it's asking you, the presentation layer encrypts and decrypts. But it also it converts the data that's intended to be received by the application in another format. And what I mean by that, let's say you have a Word document. It's going to convert it to an ASCII2. If you have an image, it's either JPEG or it's a GIF, or you have an MP3 or MP4. So that's another thing that the presentation layer. Normally, when you get questions on the presentation layer at this level, meaning this course, it's going to have encryption or decryption somewhere in the question. The application layer is actually what you can physically see. So when you go to your web browser and you type in www.wgu.edu, you're looking at the application layer. Now, the application layer, it supports the protocols of what it is you're trying to do. So if you're trying to access a website, it's going to support HTTP or HTTPS. Those are protocols for the website. If you were trying to upload or download or access a file, this is the protocol, file transfer protocol. Your email, you have simple mail transfer protocol, but you also have POP is another email protocol. IMAP is another email protocol. Telnet is also at the application layer, and you'll see that in the reading material. But just remember that it supports the protocols, websites, accessing files, dealing with our emails, any of those protocols. So those are just that's a brief description for each layer with some keywords. There's so much more to the OSI and the TCP/IP model, but for this course, you do not need to know all that information. Knowing those keywords, no matter, like I said, how the question's worded, it is going to tell you if it's, if it's TCP or the OSI. But even if it was talking about TCP, the TCP/IP model, remember I said the same functions and services, you just have to combine those. So when you go to take the exam on that whiteboard, I would go ahead and write out the layers, the 4 layers for the TCP/IP model, and right next to it, the OSI, so that you can see that layer 1 of the TCP/IP model is called the network interface layer. Layer 2 of the TCP/IP model is the network layer, but it's layer 3 of the OSI model. So definitely make sure that you do that. And if you are struggling with any of these areas, don't hesitate to, schedule a time to meet with me, or if I'm not your instructor, one of the other instructors. All right, so I have a few quiz questions for you. First one, TCP, it functions at which layer of the OSI model? Where does TCP function? Transport layer, yes. What was the other protocol at the transport layer? Do you remember? UDP, which one is connection oriented? TCP. What do we call UDP? If TCP is connection oriented, what is UDP? You remember? Unreliable, yes, very good. All right, next question. HTTP, it functions at which layer of the OSI model? Layer 7, the application layer. What were some of the other protocols that live at the application layer? Do you remember? FTP, Simple Mail Transfer Protocol. IMAP. There's a couple other ones. Depending on what part of the United States you live in, yes, POP. So I'm from the Midwest. I call a Coke a POP. So that might help you to remember. And then don't forget that Telnet is at the application layer. We have the DHCP server. That is the server that's set up in our network organizations that distribute the IP addresses for the devices. And you don't need to know how that functions, but the DHCP server or DHCP does sit at the application layer. And then the next question is the network interface card. It functions at which layer of the OSI? Where does the NIC card function? It's not layer 1, because it operates at layer 1. It functions because of that unique MAC address. Yep, at layer 2. So remember, it operates at layer 1, it functions at layer 2. There are no other, it does not go past layer 2. So layer 1 and 2 is where the network interface card is going to be working. All right, so let's look at the fundamentals of virtual and cloud computing. So you're definitely going to get questions on the exam over this. Cloud computing has been around for a very long time, and so is virtualization. They're not new. I do think that on a personal level, we are using cloud. All of us are, especially if you have Microsoft 365 with OneDrive, our phones, when we upload or back up our cell phones or our smartphones, we're using basically a cloud hard drive, and it is in the cloud. Keywords, when you get questions, oh, sorry, I'm moving ahead of myself. So virtualization, there's lots of different types of virtual machines, and a virtual machine kind of simulates something that's physical. So you've got hardware servers, workstations, storage, network devices, all can be virtual machines. Virtual machines can be created in the cloud, but they can also be in-house. They don't have to be in the cloud to create a virtual machine. In order to create virtualization, you have to have a hypervisor. There are two types of hypervisors. There's a type 1 and there's a type 2. Now, a type 1 is called a bare metal hypervisor. It loads directly on top of the hardware, and it's usually used on servers. Now, you're going to have multiple users accessing a type 1. Let's say an organization has created a virtual server. They've installed Microsoft 365. It's cheaper. They do not have to worry about employees having it on their desktops or their laptops. So they're having them all access this virtual server to use Microsoft 365. That's an example of a bare metal hypervisor or type 1. Now, this is misspelled. I need to fix that. But these are some examples of some well-known type 1 hypervisors. I think they give you a few others in the examples in the material. But just know that you have to have a hypervisor in order to create a virtual machine. And there's two types. Type 1 right here is a bare metal. Type 2 is what we call a hosted hypervisor. Now, a hosted hypervisor is loaded on top of the operating system. It's usually on one device, a personal computer, can be the device you're using at work. It's just you using it. It's not a bunch of other employees or individuals trying to access it. An example of a type 2 type using it is Microsoft.
Do I gotta know the brands?
Employees having it on an organization has created it's usually used on servers. Now, you're going to have multiple users accessing a type 1. Let's say an organization has created a virtual server. They've installed Microsoft 365. It's cheaper. They do not have to worry about employees having it on their desktops or their laptops. So they're having them all access this virtual server to use Microsoft 365. That's an example of a bare metal hypervisor or type 1. Now, this is misspelled. I need to fix that. But these are some examples of some well-known type 1 hypervisors. I think they give you a few others in the examples in the material. But just know that you have to have a hypervisor in order to create a virtual machine. And there's two types. Type 1 right here is a bare metal. Type 2 is what we call a hosted hypervisor. Now, a hosted hypervisor is loaded on top of the operating system. It's usually on one device, a personal computer, can be the device you're using at work. It's just you using it. It's not a bunch of other employees or individuals trying to access it. An example of a type 2 hypervisor, let's say that you've got a laptop, it has a Windows operating system installed on it. You want to also use Linux. You do not want to buy another laptop. It's too expensive. Don't want to deal with two separate laptops. But you also don't want to uninstall your Windows operating system. You can download the Type 2 hypervisor on top of your Windows operating system and set up your Linux. Now you've got one laptop and you've got two different operating systems. Cloud computing. This is what I was talking about before when I was skipping ahead. So if you get a question on the exam or on a quiz that basically states for you to choose a scenario that best describes cloud computing, the key word that you want to look for is internet. Can't have cloud computing without the internet because it's not in the cloud if it's in your on your premise or in your environment physically. So it's usually through the internet, and it can be hardware or software. It's so the key word there, no matter how something is worded, just look for internet. Some earlier cloud computing providers was Gmail and Yahoo. If any of you are old enough to remember, there was a time where with our email, you had to download it and set it up on every device you wanted to use. So if you were checking your email at work or in a school lab, and then you went to check it on your home, uh, you could delete that email. Say you looked at it at work, you opened it up, you downloaded it and set it up, your own personal email, and you ended up deleting the email. When you go home, it actually didn't delete it because it's downloading on your system. So we don't really deal with that anymore. We don't have to download the emails. We are able to read our email in the cloud without having to download, which actually benefits us with certain types of viruses not being able to be downloaded on our systems. Now we're going to talk about, because we're talking about cloud, let's talk about cloud service models. And so you have an infrastructure as a service, a platform as a service, and software as a service. Now, an organization can use all three. They can pick one or the other, maybe they only use two. But really, it's designed to either save the organization money or just make things a little easier. So, infrastructure as a service, an example of this, you've got a business that's on a tight budget. It is very expensive to purchase network devices. It's tens of thousands of dollars. They don't last usually, but maybe 2 to 3 years. And it would be a lot cheaper to find a cloud service provider that you can lease or basically rent a server so you don't have to buy it. Now, it is empty, there's nothing on it. You're just actually renting or leasing the hardware part of that server. What makes it not only saves the organization money, but it can be beneficial because if it's empty, then the business, they have the ability to set it up any way they want. They choose their operating system, they choose the software, they choose the uh, uh, types of backups. They set the whole thing up and get their employees to access it. Kind of like you rent an apartment and you have to furnish it, or you buy a filing cabinet and you have to put files in that cabinet. So they have the business is responsible for setting it up. Now, platform as a service, an example of that, let's say you build a website for your business. You have to have the software to build the website. Now, if you're not using a platform as a service, you're going to have to purchase a web server operating system. You're going to have to contact your internet provider and see if you have enough bandwidth to handle either employees or customers accessing your website. It is a lot cheaper and easier if you find a web hosting site to upload your, which is a example of a platform as a service. But you find a web hosting site, it costs you money. You have to pay a yearly or monthly fee, but you upload your website. They provide the web server operating system. They're backing it up, they're updating it, patching it. All you need to do is manage your website. So you have to manage it and change it. They can't change your website. You need that software in order to be able to make the changes. You're responsible to get customers or your employees to access it. They provide everything else. If you're a programmer and you create a mobile app on your device, you need a platform to upload it to test your code. So those are examples of platform as a service. Software as a service, we're using it right now with this WebEx. You got to choose whether you want to use an online version or download it, but you don't have to manage it. You don't do anything but use it. That's what software as a service is. Microsoft 365 is a good example. You can access it from any device. You can upload it. You can use the downloaded version, or you can use the online version or download it. Salesforce, Facebook, those are all examples of software as a service. Now, how it helps an organization is, let's say Microsoft Office. It costs a lot of money for Microsoft Office, and depending on how many employees they have, it can be very expensive to purchase a license for each one of their employees. And when you're using Microsoft Office, not 365, but just Microsoft Office, the versions change. So if you're using one version and then you have to update to a new one, it's going to cost you more money, and you have to still get a license for each employee. Plus, it's limited. With a license, it's usually allows you to download one copy on, say, a desktop and one on a mobile device, and you had to manage it. If you were a network administrator, you had to make sure that no one was using, two mobile devices and a desktop because you would get fined for that. So with Microsoft 365, an organization can, instead of buying separate licenses, they'll pay a yearly fee, and all their employees can access it either on, line or download it, but multiple devices. They don't have to manage it like they used to. Software as a service is just you as an individual or the organization. They're just using that software, and they're not having to patch it, update it, back it up. They don't do any of that. So now I do want to point out that if you are using Microsoft 365 and you create a Word document, you have to save it. You are responsible for that. But for the overall use of that application, you have access to all those different devices. Then I took this from an image from the course material, and so it just kind of shows you what you, the business, is responsible for and what the cloud service provider is responsible for. And then we have cloud deployment models. We've got a public cloud, a private cloud, a community cloud, and a hybrid cloud. Now, a public cloud is open to the public, but that doesn't mean it's free. It means that basically anyone can pay to use it. But just because you're using a public cloud doesn't mean that anybody can access your public cloud. Kind of like your internet access. Your internet, your ISP provider in your area, anyone can pay for internet, but your neighbor can't access your network just because it's open to the public. Now, examples of a public cloud are Microsoft Azure, Google Cloud Platform, and Amazon AWS. Those are examples of a public cloud. A private cloud is either you are part of an organization, either by being employed or you're a member. The Department of Defense, the DoD, is an example of a private cloud. You either have to be affiliated with the government or part of the military in order to access it. So, sorry, my dog is coughing. And then I'm going to skip past and go down to the hybrid cloud. Now, a hybrid cloud is a combination of a public and private cloud. So an example of this could be you've got the Department of Defense, the DoD is a private cloud, and it's implementing Microsoft Azure, which is a public cloud. That is an example of a hybrid. The community cloud, on the other hand, it's two or more organizations that are sharing exclusive access to the infrastructure or computing resources. So, for example, you've got IBM, Hewlett-Packard, Apple. Those are all separate organizations. So just remember, community cloud is two or more organizations. When we're talking about a public, private, and a hybrid cloud, we're talking about one organization. So that ends our cohort. Hopefully you found that helpful. Like I said, if you are needing help on any of the areas, please don't hesitate to schedule time to meet with myself or one of the other course instructors. You are free to go. Thank you for attending the cohort and enjoy the rest of your day.
Hello everyone, my name is Jim Nichols. I'm one of the instructors for the Network and Security Foundations course, and over the next hour to hour and 15 minutes, we're going to be going over cohort 2, which is the Introduction to Network Security. All right, starting out with lesson 1.1, some network security foundations or fundamentals. The purpose of network security, basically our job is to protect network assets. That could be the network itself, any IT system like server or other device, applications or data. There's a lot to protecting it, but we need to protect all of those devices. Prevent any malicious activities, meaning we want to prevent misuse, modification of data or information, disruption to services, or any destruction of data. We want to make sure that we prevent unauthorized access to network resources. We want to allow the right people to have the accesses and prevent everyone else. And of course, while we're doing all of this security and protection, we need to make sure that we are ensuring availability for those people who have a legitimate right to use it to access those resources. Now, there's many aspects to network security, everything from securing access to the network itself, the different network applications, the devices and systems that could be routers, switches, firewalls, servers, storage devices. We need to be mindful of the network protocols, meaning how we transmit data across the network, any network services that we may have, and more importantly than all, the data itself. An organization has no asset more valuable than their data, and we want to protect the confidentiality, the integrity, the availability of that data. Now, there are three different approaches a person can take or a company can take to security. One is called the compliance-based approach, also known as the standards-based approach. For example, if you run a doctor's office, you need to follow HIPAA regulations. If you're working in an educational institution, you need to follow FERPA, guidelines. These are basically regulatory, oftentimes legal requirements of things you must do and how you must do it to be in compliance. Other companies will choose to use a risk-based approach, meaning the internal IT and security teams identify certain risks, and then once they find them, they go ahead and determine how they're going to deal with them, and they mitigate those risks accordingly. We would like to avoid the ad hoc based, which is basically implementing security without any real rationale or thought process. It's very haphazard, it's not a great way of doing things, and we want to avoid that where possible. Now, understand that as you learn more and more about security, you're going to discover that there's kind of an inverse relationship between the two. The more user-friendly, plug-and-play, and convenient something tends to be, the less secure it is, and vice versa. The more we lock something down and secure it, the less usable it is. We need to find that balance where it's as secure as it can be while still maintaining usability, and it allows the people using the technology to do what they need to do without being too cumbersome. Now, there is a great deal of security terms you need to learn. None of these are difficult. It's just something that you have to memorize. So an asset is anything of value to you or the organization that you're implementing security to protect. Could be data, devices, software, hardware, whatever the case may be. It's what we're trying to protect. Vulnerabilities are a flaw or a weakness either in the hardware, the software, or the facilities that a bad actor can take advantage of to compromise our security. An exploit is the methodology or the mechanism of taking advantage of that vulnerability. If that vulnerability is a flaw or a weakness, there has to be some type of tool, whether it's a program, a script, custom code, a technique. It is the how we take advantage of that vulnerability. The threat is anything that could potentially cause harm to our assets. Could be things like viruses and malware, people like hackers, or natural disasters. An attack is the action taken to